Okay, 7.5 exercise 8, the old fence on the barn. This is a bit of a tricky one, so you might have to watch this more than once. A rectangular dog run, so that's an enclosure, is to be built with 120 feet of fencing. One side of the dog run uses the side of a barn, and so what values will the width have that such an enclosed area is less than or equal to 1,600 square feet. We're going to do all of these things down here, at least the top three. We've read it carefully, we understand it. We're going to be building a diagram of it so that we can understand it better, we can see it, and we're going to let x represent the unknown variable and represent everything else in terms of x. So x was going to be the width of the enclosure. So let's draw the barn here. I'll just draw this little barn here, call it B, and there's going to be an enclosure on it that looks like that, and the dog's going to run around inside there. I'm not going to draw the dog. So we have the width that we call x, and this is x here too. And this length here, we have to define it in terms of x. Well, we know that there's 120 feet total, and that's x, so 120 minus this x and that x, or minus 2x, actually gives us a description of the length here, but using x. And that means that the area, of course, is x times that stuff. So the area is x times 120 minus 2x. And that has to be less than or equal to 1,600. So we've got the makings of a quadratic, and we're going to solve it, and then we're going to deal with it like we've dealt with the quadratics earlier in the chapter. So this, once we put the x back in there, is 120x minus 2x squared is less than or equal to 1,600. All those are divisible by 2, so we can simplify and change that to 60x minus x squared less than or equal to 800. And in order to make this a proper quadratic inequality, I'm going to move everything over to one side. Because I've got a negative x here, I'm going to move everything to the right hand side, leaving 0 on the left. So 0 will be less than or equal to, well, I'm going to move the negative x squared over, so it becomes x squared. I'm going to move, oops, that's 60x. I'm going to move 60x over, and that's going to become minus 60x. And the 800 was there already, so plus 800. Now we can see that we can factor that because 800 happens to be 20 times 40. 10 times 40 is 400. Twice that is 800. So 20 times 40 is 800. So 0 is less than or equal to x minus 20x minus 40. So, like with all quadratics, the first thing we're going to do is we're going to draw a number line, and we're going to place some values on here. We can place 0 on there. We know that the width, we already know the width is a minimum of 0. If the width was 0, then the area would definitely be less than 1,600. And the dog wouldn't have a very good time. But we know that x is going to be greater than or equal to 0. And I like to write it that way because I'm going to put a maximum here. So let's put 10, let's put 20, let's put 30, let's put 40, let's put 50. Because we know about these points. We know that at 40 and at 20, the area is going to equal 1,600. Because if we rewrote this as a quadratic equation as opposed to an inequality, if 0 equaled this junk, we would solve for x by saying, well, x could equal 20 or 40. So when x equals 20, we know that the area will be 1,600. Don't believe me? Put it in here. 2x is 40, subtracted from 120 gives us 80 in here, and 20 times 80, 1,600. So if we plug 40 in here, we'll get the same thing. We'll get 1,600. So these two are solutions to the quadratic inequality. The question is this stuff in here a solution set? Is the stuff out here a solution? Is the stuff over here a solution? And are there other boundaries that we should pay attention to? Other maximums or minimums? So first of all, let's see if it's the stuff on this side, the middle, or that side. Let's try 10 in the equation. Maybe somebody will get the phone. Probably not. So, it's hard to ignore. Oh, good. Okay. back to this. So 60x minus x squared, is that less than or equal to 800? Let's test 10. So that if we put 10 into this equation, this is the equation we're doing because it's my simplest one to test with. 600 times 10, or sorry, 60 times 10 is 600, minus 10 squared, or minus 100 is 500, is less than or equal to 800. So yes, 10 is in the solution set. So we do know it's down that away somewhere. What about 30? Is 30 in the solution set? Well, 30 times 60 is 1800, minus 30 squared. 30 squared is 900, so 1800 minus 900 is 900. Is 900 less than or equal to 800? No, it's not. So not the stuff in the middle. And what about the stuff up here? Well, let's test 50. 60 times 50 is 3000, minus 50 squared. 50 squared is 2500. So that's 3000 minus 2500, and that gives us 500, and 500 is less than or equal to 800. So yeah, the stuff up here. Okay, so it's going to be greater than or equal to 0, and it's going to be less than or equal to 20, or x is also going to be greater than or equal to 40, and is there a maximum up here? Well, let's think about this logically. Now we don't need to calculate it, we can just think about it. If we had the barn, there is a barn, with width of 0, we just plaster the fence up against the barn, smash the dog right in there, it would be less than 1600. So that's 0. So this area here. Okay, and that's what this tells us. Anywhere in here is a solution set where if the width is between 0 and 20, including the 0 and the 20 itself, you will end up with an area less than 1600. So 40 or greater, but how great can it be? Well, I'll tell you right now, the maximum size that it could be is if you took the barn and you took your 120 feet of fence and you drew the fence out that way and right back again, right against there, and squished the dog again. And for 120 feet of fence to do that, you need a width of 60, there and back. So we would be a maximum of 60. Now I arrived at that logically, less than or equal to 60. I didn't have to calculate it, because I know that there's a maximum amount of fence.